Okay, hello everyone. My name is Jasmine Noel. I'm Senior Product Marketing Manager here at ReversingLabs. With me is Tomislav Peričin, our Chief Software Architect and Co-founder. We're going to take you through a demonstration of how Spectra Assure will help you stop supply chain attacks. Okay, great. So if you take a look at the major software supply chain attacks over the last couple of years, you'll see that they are mostly on commercial software. I mean, it's a very attractive target for supply chain attackers because they can tamper with the software updates and embed malware and trust that, quite frankly, enterprises will deploy those updates without significant security testing for a variety of reasons, right? It could be, well, this software is from a trusted vendor, so it should be perfectly safe. Or maybe it's their tools can't fully test very large or complex packages, or can't detect, malicious code that's being introduced. Next slide. So that's one of the reasons why this Gartner report is very interesting, because they explicitly stated that the scope of security testing has to expand beyond traditional checks for software vulnerabilities, right? And they encourage people to start looking for malware and malicious code, which traditional application security testing tools and SCA tools just don't do. In other words, if you go to the next slide, you'll see that we have to start knowing when commercial software starts to behave like malware, right? And this will be the thrust of the demonstration that Tomislav is going to take you through, 3 examples in a few minutes. Okay, next slide. So when checking through the software, it's important to check for these indicators of supply chain attacks before shipping the updates, right? Because if that happens, then as a software producer, you can actually stop the release, do some remediation, and limit the downstream impact of any attack that happens, right? But it's also valuable for enterprises who either buy or use the software to assess the risks themselves before they deploy, right? That way they can be proactive in preventing malware or any other attack artifacts from entering their environment from the beginning. Next slide, please. Okay, and now think about the risk analysis. It has to actually cover the entirety of the software package, So while attacks using open source components, get a lot of media coverage and there's a lot of research done on them, attackers can embed malware into proprietary and commercial software components just as easily. At ReversingLabs, we also see all sorts of malware getting embedded in just plain files and other artifacts that gets pulled into a software package before release, right? So this is what our products, Spectra Assure, has been built to do, to provide visibility across all 4 of these areas and do a risk analysis on each component that we uncover from that software package. Next slide, please. Okay. So when I talk about risk analysis, what we're doing is we're delivering insights across 6 areas of software supply chain threats and exposures, such as malware, or has your software or CI/CD infrastructure been tampered with? Or are you exposing some secrets that could make you vulnerable to a future attack? Things like that. So you get a much more comprehensive profile in order to make your decision, right? We also rapidly process these very large and complex files. So it can be used literally for every software update, whether it's, a small little software component that you're delivering an update to, or whether it's a huge software container that's multiple gigabytes large, right? We can process that in a relatively reasonable amount of time. Another advantage is the fact that you don't need to have the source code. You don't need access to the developer environment. You don't need access to the developer's build manifests in order to get, a full software bill of materials, right? Because what we're doing is we're analyzing the binary. And we also will give you that complete risk analysis, because as we discover and uncover each component, we're doing that risk analysis. So that makes it suitable for both software producers and software buyers. So that's all I have to say at the moment. I'm going to hand it over to Tomislav, who's going to take you through the rest of how we prevent, how we will stop software supply chain attacks. Tomislav?
Thank you, Jasmine. So, the question is, how can you actually address software supply chain attacks? And as Jasmine was just saying, ReversingLabs or Spectra Assure looks at six different categories of risk. Two of those categories, which we're going to focus on today, are called malware and tampering. And now, what we mean by these categories is the following. Malware relates to any kind of known malicious artifact detected through various technologies, things like signatures, functional similarities, even certificate, blacklisting, whitelisting, those types of things can be used to identify known pieces of malicious code. What ReversingLabs also does, we employ a plethora of machine learning algorithms to kind of be proactive and try to detect software supply chain attacks and traditional malware as well before they are known and before the signatures for those particular threats are generated. Now, software supply chain attacks are a little bit different than your conventional malware. They often refer to tampering of the code itself or of the build processes, of the artifacts used during the build or in deployment processes. So that's why we have a separate category specifically dedicated to finding threats which you would most commonly see in software supply chain. And in both cases, the outcome for our detections are what's shown in the middle. Policies which have priority, they have severity, and the estimated level of effort required to remediate any particular threat. So priority zero issues are those which have the highest severity, and they have the full capability of stopping a software release. Because our solution can be easily plugged into CI/CD processes, our passing or failing decisions can be applied to basically stop release from going out, or if you are on the consumer side, to actually prevent you from deploying a release which might contain, malicious code. Any one of these six categories of risk that we have on our screen has the capability of blocking a release, and our users have the full ability to customize the policies to their risk tolerance. What we have built is a very easy way to level set, and we basically call it ReversingLabs levels, that easily and gradually takes you to the maturity process of figuring out, what kind of high severity issues you want to have in your environment. But regardless of, are you dealing with secrets or vulnerabilities or hardening issues, all malware threats and all tampering should always be stopped at the most basic level, and no software should be release which contains those types of issues. So for today, we've decided to look at three relatively recent software supply chain attacks, which are basically realistic examples of what can happen. And we want to showcase how our platform can be used to detect both at current time, but also to be preventative and prevent such releases from being ever released. So we want to look at it from both standpoints. Can we know that the software supply chain attack has been happening before it became common knowledge? That's a typical question we get, and that is something we are deciding to focus our platform on. So those three examples we're going to go through are in no particular order. An attack which happened on an open source library called UAParser.js. This happened, I believe, in late 2021. And here we have a nice little diagram which kind of showcases what types of threats can UAParser JS compromise be labeled as. We've chosen to use the framework that's commonly used by software producers called the Salsa framework, and they have a really neat visualization that we like. It tries to map threats on parts of the software supply chain or software build process. And here it is debatable where you want to place UAParser.js. It can be one or two things because the attack happened in a specific way. So UAParser.js is an open source library published in npm, but the attackers have pulled down the original source and they have built it themselves to then upload that modified package to the public repository. Now, the reason why this was possible is because they had access to the account which was able to publish these packages. So basically, the compromise happened at the developer account level. And since most software package managers have the ability to automatically pull down the latest changes, as long as those changes are compatible with the current release, a lot of people who had been continuously updating UAParser.js became compromised. Now, you do want to update your dependencies because often that resolves the issues of not only software quality, but also various types of vulnerabilities which might be affecting the package. But in this particular case, that does expose you to risk as well. Uh, Now we want to jump out of the presentation mode and just jump into our platform so we can kind of showcase how Spectra Assure sees this particular package. So here on front of my screen, I have our web interface that allows its users, or which are commonly both developers and software publishers, but also security people in SOC, to upload any number of packages they have and have them analyzed. Now, this is specifically tailored to software, analyzing software, because it has the ability to not only create neat projects as I just did, but also to organize these projects by packages and having those packages be versioned. So our first example is UAParser.js, and if I select that, you'll see that I have uploaded 3 different versions of this particular package. Versions 0.28 was the last known good version of the software package. So this was before the attacker actually embedded their malicious code within the package. And then 29 is the first malicious one, and then release 30 was the first one to actually remediate the issue. Now you can see this linear progression, and what's neat about the platform is that it automatically analyzes files and provides you with differential analysis between various versions of the package. So here, if you go into version 29 and you kind of expand this row, you'll be able to see that the software quality has worsened, and the reason why is because we've detected both tampering and malware in this particular package. Now, malware says that there's 6 known artifacts of software supply chain attacks, and that is accurate. So there's various files being embedded within the package, and those are all malicious artifacts that the attacker has chosen to add. Now, there's more details. If you click on the package itself, you'll get this detailed report, and then you can dive into any number of these things. I just want to highlight on the issue side that we have a category called malware detection, and that this is causing a P0 issue, which will fail the package. And the reason why we're doing this is because there are known software supply chain artifacts within the package, and furthermore, our analysts have manually vetted these artifacts as well, and with high degree of confidence, we're saying this is a known software supply chain attack. Now, that is something which is trivial to do once you know the package is malicious, but it's very hard to do before that is common knowledge. So what we've done is we've created a couple of different threat hunting and differential analysis policies which look at differences between packages to be able to tell you that the package has been tampered with in a malicious way. Now, you'll see here that under threat hunting, for example, we have a couple of rules, and threat hunting is a category specifically designed for defenders who work in the SOC. But we do find that developers are more than capable of analyzing these policies as well. So what it says here that we've detected files with behaviors which are exclusively used by malicious software. And if only that was to happen, that would be a good reason for us to fail the package. Now, what we mean when we say behaviors is shown in the behavior tab. And these are, quite simply put, human-readable descriptions of intent of the code. So ReversingLabs does automated static analysis of both source code and compiled code, but we do focus more on the compiled code itself. And we're able to tell you, based on static analysis, what's likely to happen if that code was to execute. Now, there's a whole bunch of behaviors that are present within the package, and some are, from the original source code written by the developer, and some are actually introduced by the attacker. But because we said there is at least one behavior that is exclusively used by malicious code in this community, we can easily highlight what that was. So downloading files using certutil. Those who don't know, certutil is a Windows utility used to both work with certificates, but it can also be abused to download files, any arbitrary file. And in this particular case, it's being used to download malicious content. So what we've added in our latest release is the ability to kind of show more information about the behaviors. So we now expose a reason why we feel like this behavior is accurate. We give you a brief example why this behavior might trigger. But more importantly, we give you information about this specific behavior in the context of the community it's used in. So because we have this vast repository of knowledge, more than 10 billion files analyzed thus far, we know that this behavior is only seen used by malicious software in NPM. So this is a proactive way of being able to flag potentially malicious packages before they are common knowledge, just by looking and tracking behaviors. And we've done this for a number of communities. The list is continuously expanding, but that is a good way of operationalizing our behavior data to prevent something like UAParser, a compromise like UAParser happening again. Now, certutil is a common technique used by attackers, and frankly, even before the attack, this behavior would be good enough to actually stop it. But we do show a lot more, actually. So for those who are willing to dive into the nitty-gritty details, you can actually audit all of the changes between package versions. So I'm comparing versions 28 and 29 here, and I can see all the files being added and modified. And the files being added, this one, the batch file, actually does show that it's malicious because we actually know that now, but it lists all of the behaviors present on the file. And one of them, as I said, was downloading files using certutil. So since the attackers did a common technique, we are able to detect and prevent that type of an attack. Now, since we actually analyze versions one after another, we can also show you something we call differential analysis. It's a special kind of threat hunting policy, which tells you that we've detected indicators of tampering that resemble a known attack. And we have a number of these ranging from, UAParser.js, 3CX, and SolarWinds as well. So all common attacks that have patterns of tampering present within them. So even if there was a new package which used the exact same techniques, even slightly changed, we would be able to detect it. And you get full confidence that we are looking for these things. If you look at the Issues tab and just open differential analysis, you'll see all the types of software supply chain attacks we've currently cataloged. Now, as I said, this is a list. This is continuously growing. Now, this is our first example. We looked at an open source library which was compromised by a malicious actor. In our second example, which we're going to jump into, we have something a little bit different. So this is a commercial application. It's an application in this particular case for Windows, and it's compiled binary. We don't have access to source code, which we did for UAParser.js. And it's a different type of a compromise as well. So in this particular case, what we feel happened is that there is a local repository inside 3CX, which holds all of the binaries being used to build their final package. And we feel that a nation-state actor in this particular case has replaced two of those binaries with malicious counterparts. So this is another type of a vector where Spectra Assure can actually be applied. And in this particular case, there's some files which were modified maliciously. The code was added in one particular open source library, and then another library was used to actually deliver the malicious payload as well. Now, both can actually be seen in Spectra Assure as well. So I have another example that I've preloaded here under 3CX. We have a desktop application. And as before, we've continuously tracked software packages and we've looked at differences between versions. And as you can see, threats are starting to become detected on version 4.07. So again, you can go into all of the issues we detect, and you'll note that under differential analysis, we're quite explicit here to say that this application has indicators of tampering that resemble 3CX desktop app software compromise. Again, if it was a different package using the exact same techniques, it would still be detected. But on the diff itself, you can actually see that if you want to go into the nitty-gritty details of how that's actually detected. So if you search for the files that were tampered with, so there's two. One is called FFmpeg, and that one is the one we actually flagged. But also, what was interesting there is that it contains specific behaviors which are exhibited by malicious tools. So it contains SIG-loader tool functionality, which the actor used to embed malicious payload into the binary itself. And as you can see, it references another library within the package which contains the malicious payload itself. So all of this just started happening from one version to another. And the reason why we felt comfortable saying that this package contains malicious code right at the bat was when you look at the Direct3D compiler file, you'd be able to see that the file signature it has only partially validates the integrity of the signed content. Now, again, this is a known pattern of software supply chain attacks. Some attackers like to append data after the certificate. We do detect that, and when that is first found in a software package, that is one of a type of a thing that needs to be addressed by the developer. It's not common. It's only used in a specific circumstance, basically to tag installation packages. Here, it's embedded deeply within the installation package itself. So the question is, why is this happening? So to us, this was a sure indication that something is wrong. Direct3D, for example, is a very old binary. It's signed by Microsoft, and Microsoft does not do these types of post compilation and post signing changes. So that's one of the ways you can actually be proactive and use binary analysis that we do to detect and prevent software supply chain attacks. And then finally, we have another example, and that is the example which, for us at least, started the whole software supply chain attacks in the in the public eye. So attack on SolarWinds was specific because you had another nation state actor which compromised the build environment. The build infrastructure in this particular case was compromised, and there was a malicious binary being run as the software was being compiled, and it injected additional source code files to the compiler, and then that resulted in a final binary being infected, then signed and released to all of the customers. Now, this is a perfect example for reproducible builds because only one replica of the build environment was compromised. Spectra Assure has been designed to actually address that challenge. So since then, SolarWinds has gradually moved to and now fully uses reproducible builds as a defense mechanism against software supply chain attacks. Because if only one of the replicas, and they use a couple, is tampered with and there's malicious code running there, there will be differences between the final package being built. However, the problem with reproducible builds is that not all programming languages support reproducible builds, and not all packages can be built in such a way that they are bit-to-bit equivalents. So simple hash checks don't really work in this particular case. So we've designed a solution to address that problem. So in our particular case, I have an example here for reproducible builds, and this is a demonstration that we built ourselves internally. So it's a simple application which basically just produces hello world text on the screen, but we built it twice. And in one of those replicas, the file was intentionally modified. So we created a bit of code which injects a new malicious payload into that particular replica. Now here, even though we are building the application for Windows with Visual Studio and the build is perfectly reproducible in this particular case, it does not need to be, because ReversingLabs Spectra Assure looks at the behavior differences and other low-level data about the package itself. So hashes don't really need to match. So basically, I've uploaded the package and I've uploaded its reproducible build. And as you can see, a reproducibility check has failed because there are two differences within the package. And if I look at the details, I can quickly go into our reproducibility tab and see that the builds between the reference and the reproducible build are not equal. So hashes are different, obviously, but they don't need to be the same. What's different is there is a functionality change. The file has changed its low-level signature. As I said, we use a specific type of functionality hashing to look at these differences and see if the file has more functions or are they used in a different way. And there was additional behavior being added. So the malicious copy actually just displays a text dialog screen, and that's showcased here as well. So the text dialog screen basically tells you this is a malicious version and you should actually fail the build. So those two differences can be very subtle, but again, with reproducibility, there should be no differences. And this works on a simple file like this or on a giant package which has millions of files. They're all going to be checked individually, one against another, and all of the differences are going to be enumerated. And again, if you want to see the differences, you can actually go into the details and see, why this particular package was failed. Now, with those three things in mind, this is a ReversingLabs way of combating software supply chain attacks. So today we've shown how you can use Spectra Assure to both detect known software supply chain attacks and known issues of tampering, but also leverage its unique static behavior analysis to be proactive and even leverage its automatic detection capabilities to block certain types of software supply chain attacks from happening. But ultimately, you also want to deploy reproducible builds as well, because they address a unique challenge that was seen in a SolarWinds attack, which is one of the build environments being compromised. So if all of these things are put in place and they are continuously monitored and just included in CI/CD settings, you have a pretty good chance of spotting software supply chain attacks before they become common knowledge, and you get assurance that the package is what you intended to be built. Now, in addition to software supply chain attacks and malware, we are also looking at other software quality aspects. So we look at licenses, any encoded secrets, vulnerabilities being present, and hardening issues present within the file. So all of that kind of deserves its own webinar. But today we wanted to showcase our capabilities when it comes to detecting and preventing software supply chain attacks. And with that, I like to turn it over to you. If you have any questions, I will be happy to answer them.
Just as a reminder, you can use the Q&A button to ask any questions that you have. I do have a couple things queued up. Tomislav, so one of the questions we have here is, how hard or easy is it to get started with scanning your software? And are there any specific pitfalls that someone who's brand new should avoid?
Great question. So the reason why we've designed our solution in a way to scan the final build artifact is because we wanted it to be non-intrusive. So we wanted to be able to scan the package as it is, as you kind of shipping it or deploying it. And that's causes the least amount of friction with developers. You already have a package that you're going to use. We just want you to scan that. There are pitfalls, obviously. If you want to take full advantage of everything we offer, this is a tool that also needs you to look at the results and be able to action on them. But if you're looking for an automated way to kind of thumbs up or thumbs down releases based on a set of criteria, it is fully capable of having its decisions applied across the CI/CD process. With levels, we can help you mature as well. On level 1, we'll stop things like tampering and malware, and we won't even look at vulnerabilities at level 1. But as you kind of move that slider further to the right, vulnerabilities start to come into play, and then secrets and so on and so forth. So think of level 1 as something where you want to start, and level 5 where you want to finish. So hopefully that helps.
So we have a bunch of other questions that are mostly asking how we detect certain types of attacks. So the recent, I think it's the XZ or XY utility attack, detecting malicious GitHub commits, or how we would scan for secrets across different platforms.
Sure. So let's address the XZ. So XZ just happened basically last weekend, and our team has been looking at it religiously since. I've scanned a few binaries, and we are now detecting XZ attack. I cannot say that we would have detected that specific type of an attack with our platform before it was common knowledge. So this is a very advanced type of an attack, and it's unlike anything we've seen so far. So you had a malicious maintainer who's been part of the project for more than 2 years, I believe, and they were so deeply embedded in the platform that they were able to not only contribute code, but also disable some of the security mechanisms on other platforms as well. So insider threats are a very difficult problem. That is something we need to consider when it comes to designing the next versions of the tool itself. But no, unfortunately, I don't think us or anybody else would be able to detect that type of an attack beforehand. After it is common knowledge, it becomes a relatively simple task for anyone, and I can just jump back into the platform. We can see it being shown as malicious, but I don't think there's a need to that. And then the second one, malicious GitHub commits. So the solution itself works on the binary content. It doesn't really look at source code. So our thesis is that you want to analyze the package as this kind of final check before you use it. And that looks at various properties of the file. So depending on types of tampering and types of malicious code being added, it should be able to detect it, including secrets as well. Secrets can be embedded not only in the source control, but also during the build itself. We commonly find lots and lots of secrets being embedded just as the package is being built. We actually helped a person. They were mistakenly packing their entire source code repository as part of the final release, and that leaked the entire source code tree, including all of the historical changes as well. So that's why we kind of advocate for checking at the end as well. It doesn't necessarily mean that you shouldn't check as far right as you can, but you also want to check before you ship, and that final package is a must to us, because it will find things that other tools will simply miss because they're looking at the wrong place, and vice versa, of course.
Thank you all for your time and attention today. Of course, if you have other questions, we will be happy to follow up with you on a later date. So thanks so much for your time.